Hello, we are team number 3. We are Ena Murillo, Juan Pablo Lizarraras, Eric Rivera, and Aldo Cárdenas, and we were told to do a system modeling for a permanent magnet motor. So we need to get the transfer function for Ws and the input voltage. Here we have an example of how the circuit looks like in terms of the input voltage, the resistance, the armature inductance, and the electromotive force, which it's connected to a motor. So the first equation is from doing Kirchhoff's voltage law on the circuit. The second equation it's from the motor to get the angular velocity. The third equation it's the counter electromotor force. And the fourth equation it's the torque in the motor in terms of the same current that we get from the circuit.
Okay, so for practical purposes and as our modeling method, what we did here is to obtain each block diagram from each equation. So, and the first step, we were interested in obtaining the input and the output values or functions, so we can model and obtain the transfer function. So as you can see here, we first isolate the equation for the current, so we can have the voltage input as an input of the function. The equation 2 and 3 were stayed the same, and the equation 4 we also did the isolation. So in this way we can have the IS as the input value, so then we can finally have the model.
Well, this is the resulting block diagram. We basically combined the block diagrams from all our different equations. The voltage creates a flow, current produces torque, and torque rotates the motor, which dictates its position. And this is the way that we simplify it. Basically, the 3 blocks on top can be simplified by multiplying them, and we're left with a loop. So we just use the method for loops that we've been seeing, which is whatever is on the top block over 1 plus whatever is on the top block multiplying whatever is in the bottom block. And we have our transfer function. Okay, and this is another version of the same circuit. Basically, what we did is we isolated different terms in the equations, and we come up with a different block diagram. But simplifying this block diagram gives the exact same answer.